Hey guys, welcome back. So in this video, we'll be discussing on the model analysis part. So this particular problem has the model analysis on the cantilever beam, where the beam is fixed on a particular position and it's left free on the other end. So the configurations of this beam, like thickness, length, have been given. We'll need to determine the mode frequencies and also the mode shapes of the structures respectively, and also the animation of the mode shapes should be displayed. So let's start the structural part in the ANSYS window. Hey guys, welcome back. So we'll be doing the structural part of model analysis in this video. So let's start with the preferences. So let's start the structural on the preprocessor element type. So we'll be adding the element type as beam to the elastic 3, clicking on OK and close it. So let's add the real constant, add. So there are three parameters over here, which is area of cross section, moment of inertia, and total beam height. So the area of cross section is given by the formula breadth into height, which is 0.01 into 0.01. And IZZ, which is the moment of inertia, it's given by the formula breadth into height to the power 3 whole divided by 12. So 0.01 into 0.01 to the power 3 by 12. So we had the height, which is 0.01. Click on OK and close. We'll just go with the addition of material models. Now we'll define the material model, elastic, isotropic. We'll add the linear isotropic material property, so which is Young's modulus. For this particular problem, it's given as 0.206 E 206800 E6, and the Poisson ratio is can be assumed as 0.27 or 0.3. Clicking on OK, rest. We just forgot to add another parameter, which is density. So we'll be adding the density now. So we are given the density value as 1830. So going with this, we have added the linear isotropic value and also the density. You can just close it. So let's move on to the modeling part. Create key points in active CS. So let's define the initial frame, which is 1, 0, 0, 0, 0, 0 on the XYZ axis. Apply. Key point 2, where the X axis will be increased by 1 unit. Clicking on OK. So now we'll be just connecting these lines with a straight line. Clicking on OK. Now we'll go with the meshing part. In meshing, size controls, manual size, and lines. You can select pick lines or all lines. I'll go with all lines because there's only one line here. And the size controls will be giving the number of element division as 5 for this particular problem. Clicking on OK. And now we'll finally mesh it. Going to mesh lines, you can just pick all. Now the meshing part is completely done. We'll be going with the loads part. So here there's a new change in this problem where we'll be working with analysis type, and starting with the new analysis, switching to model, clicking on OK. Now we'll go with the analysis option. Here we'll have to make 3 particular important changes. Switching to subspace, the number of modes to extract is 5. and also the number of modes to expand is 5. Clicking on OK. So another window will appear automatically. You can just click on OK without changing anything in that. So next we'll be going with the application of loads. In define loads, apply structural displacement. So we'll be adding the displacement load on the first key point. So on key points, just select the first key point, clicking on OK. Here the all degrees of freedom should be constrained, and also the value is 0. The displacement value should be 0. Clicking on OK, we are done with the modeling part. We can now verify our solution by going to solution, solve and current list. We'll get a pop-up window as a solution is done. You can just close it. Now we'll be working on with the plot results. So going on to the plot results in the general post processor, we'll be working on the plot results first and also the read results. So before going to the plot results, we should go to the read results and just select on the first set. No changes will appear. It's okay to not to worry, and we can just go to plot results now. Go to deform here and click on deform plus undeformed. Defaultly it will be on the deform shape only. You can just click on the switch it back to deform plus undeformed, clicking on OK. Now we'll get the first substep. Going to read results, clicking on the next set, we'll get the next subset by clicking on the working window with the right click and click on the fit. Samely, we can get the third substep by clicking on the next set and again following the same procedure of fit. So we can do this till the final set, which is 5. So there are totally 5 sets. We can move to the initial set by clicking on the first set and click on fit, and also the last set by clicking on last set and click on fit. So these values should be noted for each step, each substep, and also the frequency, the DMX value should be noted. And this completes the model analysis part. We can just animate this part by going to plot results again, counterplot, model solution, click on the DOF, and you can just click on displacement vector sum. Clicking on OK, we'll get the nodal solution for the 5th substep. So you can just go to animate, node shape, and in node shape, go to deform plus undeform, click on OK. So this creates an animation for each substep. If you go to read results again, go to previous step or the first set and click on fit. Actually, this lags out the window, but we can do it for each substep separately. So, thank you for watching.